Alright, this is day 42. Let's get it. Great game. You are given a 0 index 2D array grid of size 2 times n. So there are 2 rows and n columns, where grid of RC represents the number of points at position RC on the matrix. Number of points at position RC. 2 robots are playing a game on this matrix. Okay, both robots initially start at 0 0 and want to reach 1 n minus 1, so the bottom right corner. Each robot may only move to the right RC to RC plus 1 or down R plus 1C. Okay, let me also just do quick little I'm kind of sick today, but it's fine. I'll just do one question. I don't have I just really want to sleep today. Okay. Perfect. Let me just tune this music down. Alright. So they both want to reach the bottom right corner. At the start of the game, the first robot moves from 0 0 to 1 n minus 1, collecting all the points from the cells on its path. For all cells RC traversed on the path, grid RC is set to 0. Okay, makes sense. Then the second robot moves from 0 0 to 1 n minus 1, collecting the points on its path. Note that their paths may intersect with one another. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. If both robots play optimally, return the number of points collected by the second robot. So first of all, one thing to notice here is that there is no obstacle in movement. You can either go down or you can go right. So for the first robot, the obvious choice would be to move to a position where the points are maximum, right? To do a kind of greedy approach. But there's a second argument, right? If there is a cell down the road where the points are like 9,000 and you just missed that because you didn't choose the right path, correct? Is that possible? Let's see if that case is even possible. So we copy image, we go here. Let me just check my phone real quick. Nothing. Perfect. Let me just put this on charge. Okay. Now here, what we do, we have this matrix, right? So the original matrix is 254151, right? From 2, we can either move to 1 or 5. So we choose, obviously, the cell with the maximum number of points, which is 5. We pick 5, then we have an option to choose 5 or 4. We again choose 5 because it is greater than 4. Then we have the option of going to 1, which is the bottom right corner. So we take that and set it to 0, and that is the maximum points that we can have. Let's say this was 4,000, right? Let's say this was 4K, right? And this was 7, right? Now in this case, from 2 we would go to 7. Then we just have the option to choose 5, and then we just have the option to choose 1 because we can't go up. So we missed out on 4K, right? Right? So that is an argument here. So we could either do a DP approach, right? Because yeah, we could do a DFS or BFS kind of shit, right? And then after doing that, what do we have to return? Return the number of points collected by the second robot. Okay, now what is n? N could be very huge, right? N can be very huge. Now, is there a bottom-up approach that I can think of right from the bat? Let's see here. Now, here, if I take an empty stuff, so initially this is 1. There is no way this can be changed. So at this cell, I can it can move where? It can move down and right? So this cell I can come from here or up there, right? So this doesn't exist. So this will be 4, right? And this will be either I can move from up, or this will be, yeah, right? So this will be 2. Then here I can move from I can go from up or from the left, right? So it'll be 3 plus 4, 7, or 3 plus 2, 5. 5 or 7, whichever is greater, right? 7 here, right? Then we go here. I think I can, first of all, I can just simply populate the first row, which will be just prefix sum of all of these. So it'll be 3 plus 1, then plus 1, 5, plus 15 is 20, right? Now this is 2, obviously. Now here, we choose the maximum of these two, right? Which will be 4. 4 plus 3 is 7. Then we choose the maximum. 7 plus 3 is 10. Then we choose the maximum from these two, which will be 21, right? The answer is 21 in this case for the first one, right? This is the most optimal thing. 3 plus 2, yeah, 21. And then here, now after that is done, I also need to okay, now this is a trick. The points go to 0 at that point. Now if I make this, I don't know which of them, what path did I take to reach there. Now this is a tricky question here. Can I backtrack from here? So this obviously has to go 0. Yeah, I mean I can subtract the value of this 20, which is this one. So I came from here, so visited this, right? Then 20, I subtract 15 from this, so I obviously came from here, right? So visit that. And for the first row, there is no other way, right? If you enter the first row, if you enter the first row, the only way you can come from is from the left. There's no way you can jump from the bottom to the top, right? Because you can either go down or left. So if you enter the first row, there is no way you have came from the last row, right? So once you go in the first row, it's GG. So all of them are zeros. Yeah, in this way I can denote the path. Also I have a question here. If I switch a row from first to the second, can I go up? No way, right? Either I can go left or I can go down. So if I enter the second row, there is no way I can go up. Okay, that is also an observation here. Interesting. The first robot wants to minimize the number of points collected by the second robot. In contrast, the second robot wants to maximize the number of points it collects. So both of them want to maximize. That is what the game says. Right. Alright. Am I making this too complicated? I can make this, right? Then I can also modify the this one from here, right? Yo, Naveen, yo. Okay. I mean, I can try this. Let's also look at what the topics are. Array matrix prefix sum. Okay. Interesting. Okay, let's make this matrix. I mean, okay, let's do that. So first of all, int n is grid of 0 dot length. Now I'll make another thing here. Let's call it dp of size 2 and n, right? Now first of all, in the first row we just do a prefix sum. For int I equals 0, I is less than n, I plus plus, int sum equals 0, grid of 0 of I plus equals, or we can simply do grid or dp of 0 0 is equals grid of 0 0. Then we start from 1, then this plus equals grid of 0 I minus 1. Now this is prefix sum on the first row. Then on the second row, same loop. Now grid of the first row also, not grid, this is fucking dp, bro, what the fuck. This is dp, this is dp. Now dp of the first element is equals grid of 0 0 plus grid of 1 0, right? Then starting from the first column, dp1 of I would be maximum of grid 1 I plus math dot max of, are there any negative numbers? No. Math dot max of dp from the left, which is I minus 1, or from the top, which is 0 I, right? This will be this matrix. Now in order to backtrack, I start from the bottom right, which is n minus 1, right? What's with BG music? It's banging, bro. Just straight up bangers. Now here we start from n minus 1. This is getting too complicated in my opinion. Okay, so I start from here, right? Then I subtract this value. Also, this can be improved, and this can go out of bounds, right? Or no? No, this won't go out of bounds. But okay, let's see. Now, okay, I'm at this position. I need to pick from these two, right? If this is greater than this, then this is straight up 0. This can be moved to 0, right? And I also store the sum there, which will be 4 plus 3, 7. Now I come here. Now I choose maximum for these two, which will be 7. 7 plus 3 is 10. Now I choose 20, which is 21. 20, 15, right? 15 minus 20 minus 15 is 5. Okay. No, I can't do that. Okay, got it. Now after this, n minus 1, 1. Okay. In points A, points collected by A is dp of 1 n minus 1. Now int c equals n minus 1, call, right? While right, while r is greater than 0 and now we subtract the value from this points A, right? Points A equals minus equals grid of RC, right? Not grid of RC, but dp of RC. dp of RC. Now also, first of all, grid RC becomes 0. Points A minus equals dp RC. Now if, now I have to check if R is still 1, right? If instead of points A, let's just call it PTA. PTA. Now if R is not equals 0, or simply let's say R equals 1 and grid of R C minus 1 is greater than grid of grid or dp, grid, right? No, So I chose 21. I subtracted 1 from 21, which is 20. So yeah, I have to compare dp, not grid. dp rc minus 1 is greater than dp r minus 1 c. Then what if they are equal? Okay, now that is also a point. Shit. What if this is also 10? Then what do I choose here? Instead of 5, let's say this was 5. Now both of them lead to the same answer, right? 1 3 1 5 1, which is 10 11. Now 2 5, no, wait a second. 1 4 5 10, no, this is still the answer. What if this was 5 plus 4 9? What if this was 4? Now what would have happened? 4 5 9. This is 9, right? Then this would have been higher from here, which will be 10, right? 10 plus 11. Now 11 minus 1 is 10. I choose from. So if this was 4, 1 plus 3 plus 3 plus 3 plus 1, right? 9 10 11. If I choose this, 7 8 9 10. Correct. Okay, so it kind of makes sense. Let's see. This is probably wrong solution, but still, let's go. If r is 1 and this is this, right? Let's say even if it is equal, then c minus minus, correct? C minus minus. Okay, now this I can simplify for sure. I might be doing this the most complex way possible, but fuck it. Now if r equals 1 and if this is the condition, then c minus minus, else r minus minus, correct? Now I might need to run these two bitches again, right? dp minus 1. Okay. If R is 1 and C is greater than 0, what happened here? Next one is on out of bounds. If R is equals 1, C is greater than 0. Okay, now yeah, here is a question. Um, If R is greater than 0 and C is greater than 0, also, just in case, grid 0, 0 is 0. Okay, I fucked it. I can print grid here. Flawed logic. Yeah, this 5 is not becoming 0. It should be 004 100. Why is this 5? Now R is 0. Shit. Fuck, man. Okay. 21 minus the 21 minus grid PTA is equals dp of R and C minus 1 right? Then grid, then just C minus minus, correct? Right? Else R minus minus if R is 0 while C is not equal 0, grid of R C equals 0, C minus minus. From point I subtracted 1, which is 20. If it is equals in the same row but one column less, let's take a look at the solution. I am done with this. Please note that robot 1 and 2 can only move down once. Correct, that is correct. There are n possible paths of robot 1. Each possible path, correct, of robot 1 and robot 2 can only get one of the following total points. Top sum if robot 2 moves on the top row, if robot 2 moves on the bottom row. It means total points that robot 2 can get is max of top sum and bottom sum. What? Finally, we need to choose one path among n paths of robot 1 so that it can minimize total points of robot 2. Possible path of robot 1, correct. Possible, that is correct. Possible total points of robot 2. Possible total points of robot 2 if robot 2 moves on from the bottom row. Yep. This makes sense. Bro, amazing explanation. So top sum, he is calculating the sum of the top row and bottom sum is initially 0. Long answer equals long dot max value for int I 0, I is less than length. Top sum minus equals, okay, answer equals math dot min answer and math dot max top sum bottom sum. Answer of math dot max top sum is the sum of initial, right? Bottom sum is initially 0. So answer is still 0. No, the answer is max value, so minimum of top sum. Okay, so okay, then we move on to the next one. Bottom sum plus equals grid 1 of I. Let's take a okay. Now here what we are doing, the top sum is the sum of the top row, which is 15 plus 5, which is 20. So top sum is 20, bottom sum is 0, bottom sum is 0, answer is max. Now from 0 we are just traversing the columns here. Now top sum minus equals the initial index, which is 1. Now top sum becomes 19, this becomes 19, answer becomes minimum of infinity or the maximum of these two, which is 19, so it becomes 19, right? And we add bottom sum by, on the first row, 0th element, which is 1, 0 plus 1, right? Now in the second iteration, I becomes 1, right? Now we subtract top sum here, we subtract 3 from here, top sum minus 3, which becomes 16, right? And answer becomes, okay, okay, answer becomes minimum of answer 19 or maximum of top sum bottom sum, which is 16 plus 16 or 1, which is 16. Now this becomes 16. Yeah, I get it. So first robot, if that robot makes a turn to the last row, it can go there only, right? It can't go back up again. Interesting, bro. This diagram helps. But yeah, the way of thinking is crazy. Why won't this DP approach work? Firstly, I find the path which has the maximum points for robot 1, then I make all of its paths as zeros. Then finding the path has the maximum points for robot 2. Once in this problem, we won't need to minimize the maximum point. If we do greedily by finding the path which has the maximum points for robot 1, it's not guaranteed that we can minimize. If you find the maximum path for robot 1, then send those to 0, it becomes this. Oh, wow. So DP was not the thing. DP was not the trick. The trick was if robot 1 moves to the bottom row, it can continue there only. It can't go back up again. This was the trick. Crazy question. What a load of shit we wrote here. Let's reset this shit. Now simply we write this top sum bottom sum logic. Basically this plus sorry, so okay, yeah, this plus this, or this plus this, yeah. If we add this, the path is this. If we add, yeah, got it. So int top sum equals arrays dot stream grid in the first row dot sum. Is that the trick? It could be long. as long stream. I need to learn this Java syntax, brother. Dot sum long bottom sum equals 0. Then for int I equals 0, I is less than, let's take n. Now we subtract the element from here, I, right? Answer equals math dot max of, no, min of answer, or math dot max of top sum bottom sum. Crazy question. Okay, wrong answer. Why, brother? Should it be really long? Yeah. Okay, this doesn't beat a lot of the thing, but it is still order of n, right? What is this solution? It is still the same. Yeah, I think this is the problem here. So if I do a manual thing for int num in grid 0 top sum plus equals num, let's say if this works, yeah, this is faster. So this is way faster. Crazy. Okay, so this was the question for today, day 42. I'll be back tomorrow with next set of questions. Maybe I will do a Leetcode question. Yeah. So that's it for today. GG's.